Hematite, also spelled as hematite, is the mineral form of iron, oxide, one of several iron oxides. Hematite crystallizes in the rhombohedral lattice system, and it has the same crystal structure as ilmenite and corundum. Hematite and ilmenite form a complete solid solution at temperatures above 950 degrees Celsius. Hematite is a mineral, colored black to steel or silver gray, brown to reddish brown, or red. It is mined as the main ore of iron. Varieties include kidney ore, martite, iron rose and specularite. While the forms of hematite vary, they all have a rust-red streak. Hematite is harder than pure iron, but much more brittle. Maghemite is a hematite and magnetite-related oxide mineral. Huge deposits of hematite are found in banded iron formations. Gray hematite is typically found in places where there has been standing water or mineral hot springs, such as those in Yellowstone National Park in North America. The mineral can precipitate out of water and collect in layers at the bottom of a lake, spring, or other standing water. Hematite can also occur without water, however, usually as the result of volcanic activity. Clay-sized hematite crystals can also occur as a secondary mineral formed by weathering processes in soil, and along with other iron oxides or oxides such as goethite, is responsible for the red color of many tropical, ancient, or otherwise highly weathered soils. Etymology and history. The name hematite is derived from the Greek word for blood I plus or minus a 1/4 I plus or minus hema, because hematite can be red, as in rouge, a powdered form of hematite. The color of hematite lends itself to use as a pigment. The English name of the stone is derived from Middle French, ha copyright matite pierre, which was imported from Latin, lapis haematites, which originated from ancient Greek, I plus or minus a 1/4 plus or minus I 1/4 I plus or minus I. Ochre is a clay that is colored by varying amounts of hematite, varying between 20% and 70%. Red ochre contains anhydrated hematite, whereas yellow ochre contains hydrated hematite. The principal use of ochre is for tinting with a permanent color. The red chalk writing of this mineral was one of the earliest in the history of humans. The powdery mineral was first used 164,000 years ago by the Pinnacle Point Man, possibly for social purposes. Hematite residues are also found in old graveyards from 80,000 years ago. Near Rydno in Poland and Lovers in Hungary, Paleolithic red chalk mines have been found that are from 5000 BC, belonging to the linear pottery culture at the Upper Rhine. Rich deposits of hematite have been found on the island of Elba that have been mined since the time of the Etruscans. Jewelry. Hematite's popularity in jewelry was at its highest in Europe during the Victorian era, and has since seen a strong resurgence in North America, especially in the western United States. Certain types of hematite or iron oxide-rich clay, especially Armenian bole, have been used in gilding. Hematite is also used in art, such as in the creation of intaglio engraved gems. Hematine is a synthetic material sold as magnetic hematite. Magnetism. Hematite is an antiferromagnetic material below the Morin transition at 250 K, and a canted antiferromagnet or weakly ferromagnetic above the Morin transition and below its Na copyright L temperature at 948 kelvins, above which it is paramagnetic. The magnetic structure of a hematite was the subject of considerable discussion and debate in the 1950s because it appeared to be ferromagnetic with a Curie temperature of around 1000 kelvins, but with an extremely tiny moment. Adding to the surprise was a transition with a decrease in temperature at around 260 kelvins to a phase with no net magnetic moment. It was shown that the system is essentially antiferromagnetic, but that the low symmetry of the cation sites allows spin-orbit coupling to cause canting of the moments when they are in the plane perpendicular to the c-axis. The disappearance of the moment with a decrease in temperature at 260 kelvins is caused by a change in the anisotropy, which causes the moments to align along the c-axis. In this configuration, spin canting does not reduce the energy. The magnetic properties of bulk hematite differ from their nanoscale counterparts. For example, the Morin transition temperature of hematite decreases with a decrease in the particle size. The suppression of this transition has also been observed in some of the hematite nanoparticles, and the presence of impurities, water molecules and defects in the crystals were attributed to the absence of a Morin transition. Hematite is part of a complex solid solution oxide-hydroxide system having various contents of water, hydroxyl groups and vacancy substitutions that affect the mineral's magnetic and crystal chemical properties. Two other end members are referred to as protohematite and hydrohematite. Iron from mine tailings. Hematite is present in the waste tailings of iron mines. A recently developed process, magnetation, uses magnets to glean waste hematite from old mine tailings in Minnesota's vast Mesabi Range Iron District. Falur red is a pigment used in traditional Swedish house paints. Originally, it was made from tailings of the Falur mine. Discovery on Mars. The spectral signature of hematite was seen on the planet Mars by the infrared spectrometer on the NASA Mars Global Surveyor and 2001 Mars Odyssey spacecraft in orbit around Mars. The mineral was seen in abundance at two sites on the planet, the Terra Meridiani site, near the Martian equator at 0° longitude, and the Aram Chaos site near the Valles Marineris. Several other sites also showed hematite, for example, Aureum Chaos. Because terrestrial hematite is typically a mineral formed in aqueous environments or by aqueous alteration, this detection was scientifically interesting enough that the second of the two Mars exploration rovers was sent to a site in the Terra Meridiani region designated Meridiani Planum. In situ investigations by the Opportunity rover showed a significant amount of hematite, much of it in the form of small spherules that were informally named blueberries by the science team. Analysis indicates that these spherules are apparently concretions formed from a water solution. Knowing just how the hematite on Mars was formed will help us characterize the past environment and determine whether that environment was favorable for life. One big question, of course, is whether life ever started on Mars. This mission probably won't tell us that, but it may well lead to future missions that can answer that question. See also. References. External links: Martite Mindat with location data, Iron Rose Mindat with locations, abandoned mine research. Mars spheres image. Mars trench image showing a shiny texture of half-buried spheres, Florence Mine, Cumbria, UK. Mineraldata.org